All right, so number 5 should look very familiar in that we've seen a lot of questions very similar to it. And also, it's another really good question in that it's testing us on, all of the understanding behind a test without making us do the test. So this is really what I'm expecting us to see on the AP next week. So we can see here, we're looking at this study. Hopefully you guys tried it ahead of time. We're talking about 48 people. We see this magical keyword. 24 are randomly assigned to drive with a simulator while on a cell phone, and the other 24 are assigned to drive on the simulator while talking to a passenger. And then both groups are asked to exit the freeway, and then we have this number of people who missed their exit. So before we even move on, I'm hoping we recognize the type of test that's going to be done here, because we're already sort of seeing there's definitely 2 samples. We have that random assignment. And we're dealing with proportions. We have a number of successes out of a number of trials, an X and an N for 2 different groups. So this is a 2-sample z-test for proportions. We don't need this at all right now, but I'm hoping that we're starting to see that coming into fruition. Like, okay, this is that thing we haven't practiced very much, so let's get some more practice at it. Part A, we've seen a lot of times. Would this be classified under experiment observational study? Almost everyone who's written a practice test has put this question in there. So I'm hoping that they put this on the AP and that we nail the crap out of it. We know this is an experiment, and we need to answer the question. And we need to say why. Because subjects were randomly assigned. And I'm going to be even cuter. I probably wouldn't just stop with randomly assigned. I would say to treatment groups. And then I would state what those were. Cell phone or passenger. So, part A, we've seen many, many times. Part B, state the null and alternative hypothesis of interest to researchers. This is exactly what I was saying on number 4. I don't expect them to make you do the mechanics of the test, but I do expect them to have you set up the hypotheses. So for part B, we're coming down here, and this is when it's so important that we recognize there's a 2-sample z-test for proportions, because now we can say, aha, we're looking at how is P1 is equal to P2. Ha is that our proportions are different, right, in terms of this group and the other group. And they thought they would be more distracted. We did have a directional keyword, so we thought there was going to be greater amount in group 1. Now we need to define both groups and what these proportions are. So P1 is equal to the proportion of drivers on cell phone to miss the exit. And P2 is the proportion, and we could make sure we throw true in here to be cute about this, the true proportion of drivers talking to a passenger to miss an exit. Right? So we definitely need to define both, but recognizing we had 2 groups and this was proportions, we already got B down. Again, I really expect us to have to do a step B on the actual AP. So C says 1 test of significance that you might consider running to answer is a 2-sample z-test. And then, that thing I said I thought they would ask us. I promise you I did not look at these questions ahead of time. What conditions do we need for this to be appropriate? Then comment on whether it's met or not. So we're going to throw down our 4, even though we know the AP typically only asks for 3. We're not going to get in trouble for the 4th one. We need SRS. I guess maybe I'll rewrite this as randomization, because we have the kind of 2 different randomizations. We either have the simple random sample and a 1 sample, or we have the random assignment and a 2 sample. So randomized condition. We also have independence. We need our N to be less than 10% of the population. And we need our rule of thumb. We need what we need for the central limit theorem. What's big enough, right? So for this one, we need NP1. Ooh, actually, this is where we need to be very careful. We need NP combined for N1, N1Q combined, N2P combined, and N2Q combined to all be greater than or equal to 10. Right, so remember with the hypothesis test for two proportions, this is on that inference flowchart thing I made you guys. We do need to say under the null, these two things are equal. So when we come down here to test these, we shouldn't be testing NP1 and NQ1. We should be using the combined proportion, saying it's all just the same. It's a wash. So let's look and see if we actually met these. So randomized, we're going to say, haha, we had random assignment. So our two groups have this randomized piece. This also gives us the independence, right? We have this random assignment to our treatment groups, and our N is less than 10% of the population. We only have 48 people, right? So tons of drivers. Duh. Check that off. I'll look at the rubric and see if tons of drivers duh is okay as soon as we finish this. But this also gives us independence, so those two things alone. Like I said, they typically don't have you actually look at that one, so the two other pieces give that to you. And then the last one is one that I really think that you would have to check here. In this case, that P combined is the total number of people, the total proportion of drivers missing that exit. So that's 7 plus 2. This is our P combined from our sample. So 9 people total missed the exit out of all 48 in our sample. So that will be whatever the heck 9 divided by 48 is. So we're looking at 0.1875. So we're going to use that with our 24 from each group. So 24 times that. I don't really need to check both groups independently because they both have 24. So I'll just do that one times 24. Oh, yeah, not met. Right, they're 4.5, so they're definitely less than 10. So we haven't made it to part D yet, but let's just take a break to look at the rubric. So A, like we said, experiment because they're randomly assigning drivers to the two different conditions. Perfect. Part B, we see that they've defined P cell as proportion of drivers missing an exit on a cell phone. P pass, proportion of drivers missing an exit while talking to a passenger. Same as us. We use P1 and P2, but you can use whatever subscripts you want. Great. We're perfect. Part C, you'll see now this is where their conditions vary and it always gets super sketch. So in this case, they only looked at independent random samples, random assignment. Check. We got the randomized condition. We had random assignment. And then they looked at large sample sizes. So they didn't actually pay attention to whether we were less than 10% of the population. That's fine. Whatever. They also went ahead and did a blatant lie and used P1 and P2 even though we were supposed to use PC. Whatever. I can't keep up with the fact that there's always these weird discrepancies. If you use PC here, there's absolutely no reason that you would get in trouble. But you can see here, they basically say it is not met. They're both smaller than 10, so we can't meet it. Even if you use the rule of thumb where people use 5, it is still too small, so the conditions are not met to do a 2-sample z-test for equal proportions. All right, and then part D. Part D does what I expect them to do on the AP. They basically say, hand wave, we've done the stats, here's the p-value, right? Here it is. We've given it to you. You don't need to plug stuff into your calculator. This is no longer AP calculator. This is AP write giant sentences. Fine. So, and then it says, interpret in everyday language what the p-value measures in the context of the story and state the conclusion made with this p-value. So this is a hugely weighty part D. First things first, we need to state what the p-value means in context. That is something straight off that interpretations sheet. All right. So, the probability of observing a difference in proportions, right? Because the whole point of a p-value is to look at a probability of our sample being as or more extreme given the null hypothesis is true. So in this case, we're looking at this difference in proportions. So the probability of observing a difference in proportions as large as we did, and large as we saw in our sample. And I'm sure that I should be better at this. I should be using the actual sentences in that paper, but I'm being lazy. As we saw in our sample. And by the way, we could actually calculate what that is. This is 7 over 48 minus, that's not right. 7 over 24 minus 2 over 24. Or more extreme. That was the one piece that Schiffer had left off hers before, right? This or more extreme. Given there is no difference in proportions is 0.0683. So that's the whole definition of a p-value. Use the sentence, but it's all about observing a sample as or more extreme than we did, given that, oh my God. Oh, no difference. Okay. I did say it. I was thinking for a second I didn't say no difference, and it was like, oh no, I needed to say that. So yes, given there is no difference, that's under the null, and that's what our probability is. Or we could say there's a 6.83% chance that we would see blah, blah, blah if there is no difference. Beautiful. Now, of course, it would be very easy to forget there was a second half of this. State what the conclusion is. Remember, for the AP, their conclusion includes the decision. So you would have to say something like, since 0.683 is greater than, and of course, we'll just use our alpha. They didn't give us one, right? Nope. So we're just going to say alpha 0.05. That's our usual. We will fail to reject the null. There is not enough evidence to conclude there is a difference. Oops. In the proportion of drivers. Oops, that's not drivers. Who miss an exit given blah, 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 blah. Either being in a car with a passenger or talking on a cell phone. So just to go ahead and look at the rubric one last time. Part D, interpretation, assuming that they're equally distracting. So they started with the given. Given the null is true, there is no difference in the two population proportions. The p-value is the chance of observing one as large or larger than expected. Beautiful. So they didn't even throw in the number. We saw a previous example where they did have the number in there, and this time we don't have the number. Great. Conclusion, since it's larger, we cannot reject. We do not have statistical evidence to conclude it is more distracting. So they actually didn't talk about the proportion and just went back to the whole point of the whole experiment, which is say whether they are distracting or not. Anyways, so that is, to me, super important that we see this question. This is how I expect them to ask it on the AP. Like I said, there's no actual calculator work necessary. It's literally just what are the hypotheses? Can you check conditions? And what the heck is our conclusion with this bonus of what is the p-value? So I will tell you, I did not look at 5 before when I was talking about 4, and when we finished 4, I said, here's what I expect, and then 5 was exactly that. So this is what I think will happen on the AP, and that you should be ready for.